factors. Now for our purposes, they basically mean the same thing. A 0 is a value that makes the polynomial equal to 0. If you plug it into the polynomial, it's going to equal 0. It corresponds with a root on the graph. So in exercise 2b, we're going through and we're finding all of the roots or the zeros of a polynomial. So for this one here, I've got 6x squared plus 5x take 4 equals 0. Okay, so there's a number of processes we could use. We could jump into our graphics calculator, you could graph it and g-solve the roots, or you could go to polynomial solver. Okay, so we can use our calculator to help us there. We can use cross product method, okay, if it can be factorized. All right, and it can be factorized if the discriminant is a square number. That might be something we revise in the morning. All right, if we can't factorize it, then we can use quadratic formula. Okay, so we're assuming we sort of remember those things. We can factorize this one. There's lots of possible combinations, and so I've sort of listed them all, haven't I? I've gone, what are multiples of 6x squared? 3x and 2x, and multiples of minus 4, 2 and 2. One of them's got to be negative, but we've got to combine them in some way. So I've listed them all out, and I'm seeing here, if we go 2x times positive 4, gives us positive 8x, and if we go 3x times minus 1, minus 3x, and when we combine them, we get 5x. Okay, so that is the solution there. And then we should remember we wrap the brackets around horizontally. So what this factorizes to is 3x plus 4 times 2x take 1. Okay, we'll apply the Null Factor Law. We'll have 3x plus 4 is 0, or 2x take 1. This gives us 3x is minus 4, x is minus 4 and 3. Okay, so they are the zeros. If you take those values and put them into the function, they are going to make it equal to 0. Okay, the next one, you're looking at that z to the 4 plus 2z squared take 3 equals 0. So not a quadratic, so you're thinking, I can't do the cross product method there, but there's a super cool trick we can do with these kinds of ones. What we should do is like what we've been doing in some of the, when we're factorizing exponentials, we can go, let a equal z squared. Okay? If a is z squared, now what we have is we have z squared squared. Okay, so there we've got a squared plus 2a take 3. All right, I'm going to substitute a squared plus 2. And this is something we can factorize perfectly. So multiples of a squared are a and a, multiples of minus 3, positive 3 and minus 1. That's going to give us our solution. So we'll apply the Null Factor Law. And at this step, we can substitute a back in. What did we define a as? Z squared. Okay, we're going to keep going. And z is plus or minus 1 there. And this solution here, we're going to get plus or minus the square root of minus 3. Now, in the past, we would have gone no solution. Okay, that's what we would have done in 11, in semester 1 of year 11 spec. And then we learned complex numbers. So we are going to assume some of that basic complex number stuff for this part of the course. And the assumption is the square root of a negative number exists, and the square root of minus 1 is 9. Okay? So we can express this, just to do a quick recap for you, and keep the plus and minus there. We can express this as the square root of 3 times the square root of minus 1. Okay? So that's a surd operation. And square root of minus 1 is I. So this root is plus or minus 3i. So the zeros of this quartic polynomial are plus or minus, so we've now lost the root, plus or minus root 3i, and plus or minus 1. Okay, putting those numbers in will make the polynomial equal to 0. let's do a very quick recap of a discriminant, just to see if we can factorize it. We'll do the quadratic formula and the discriminant. Okay, so the quadratic formula, we all remember this one off by heart. B squared takes 4ac on top of 2a. Foolproof way to find the roots for any quadratic, right? So that's going to give you the roots. Now this part in here is what we call the discriminant. It's b squared take 4ac. Now, if b squared take 4ac is a square number, okay, so a square number, 1, 4, 9, 16. All right, Nick, these are the square numbers. They are 1 squared, 2 squared, 3 squared, 4 squared. Then the quadratic has rational roots and it can be factorized. Okay, so we can look at this, go, what is b squared? That's going to be 25. Take 4 times 6 times 4. All right, so what we've got, 16 times 6, 4, 80, 96 plus the 24, 132, I think, which is a square number, 11 squared, 121, which is 11 squared. Okay, so if it's a square number, then it's going to have rational roots. That's where the discriminant comes. Okay, so that's 2a, 2b. You should find it pretty easy to begin with. All right. Any questions? Good.